So what we have here is an example of a unit cell problem. These are really not terribly difficult. The problem is they could ask them a whole bunch of different ways and you get different given information, and it's a lot of unit conversion is really what has to happen in these problems. So the key to these is figuring out what you have and what you need to find. In this one we have a density of iron is 7.87 grams per milliliter, gives me a unit cell edge length of 287 picometers, and they want to know what the unit cell arrangement of iron is from this data. So just a couple of important things to remember. As soon as you know what element you're dealing with, in this case iron, that tells me a molar mass. And if I have a molar mass, that's another piece of given information that I can use. The other pieces, of course, are our density, which is very helpful, and the unit cell edge length. Whenever we're working with unit cell edge lengths, we've got to think in terms of volume there. And since we have a density, we have a mass and a volume part to that. And iron, of course, like I said, that tells me a molar mass. So I'm going to start with my given information. I'm going to start with the 7.87 grams per centimeter cubed. Notice I changed that milliliters, immediately to grams per 1 centimeter cubed. My reason for doing that is because my volume unit here is going to have to eventually match that volume unit there. And so, excuse me, as I go along, I'm going to keep working everything towards centimeters cubed in my problem. So once I've got that, I'm going to start doing some conversions. And the first conversion I'm going to do is get me from grams to moles, because grams to moles will eventually get me from moles to atoms. Whoops. And so I know in 1 mole there's 55.85 grams of iron. And in 1 mole, there's Avogadro's number, 6.02 times 10 to the 23rd atoms. And when you punch this into your calculator, you get 8 point, I'm not going to round, I'm going to leave a whole bunch of numbers here, 29 times 10 to the 22nd. My units, whoops, my units are atoms per centimeter cubed at this point. And so what I'm going to do next is take my other piece of given information, my 287 picometers, for my length of this side, and I'm going to work my way to a volume in centimeters cubed. So my picometers to centimeter conversion, if you don't know that one, it's 1 times 10 to the 10th picometers in 1 centimeter. And so I'm going to then convert this, oh wait, I'm sorry, let me back up a second here. I'm not going to do a conversion here. I'm going to get my number, and at that point I'm going to have, if I punch that in, I get 2.87, of course, times 10 to the negative 8th, and that's in centimeters, and what I'm going to do is cube this to get me 2.364 times 10 to the negative 23rd, and this is centimeters cubed. This, of course, here is my volume of a unit cell. I'm just going to label it volume of 1 cell. Now, if I know that this is the volume of 1 cell here, and I know that there are this many atoms per centimeter cubed, then I can very easily figure out how many atoms per cell there is by setting up a little proportion. So if I have 8.4829 times 10 to the 22nd atoms, I'm just going to make it AT, per 1 centimeter cubed, then I have X number of atoms per 2.364 times 10 to the negative 23rd centimeters cubed. And when I solve for that, I end up with 2 atoms. 2 atoms tells me, therefore, it is a body-centered arrangement. because body-centered, I know, has a total of 2 atoms per unit cell. So you can see none of this math is terribly difficult. It's a matter of understanding the conversions, and it's a matter of using what you have to get to what you need. A little bit of practice makes these a whole lot easier because you can kind of work your way through some of the different given information and what you can use to get with that information. If you start, for example, knowing that it's body-centered, then you know this, that there's 2 atoms per unit cell. If they start you with the side, we can get to a volume. If they start you with a density, we can work our way to an atoms per centimeter cubed. If they don't have a density, but they tell you what element you're working with or what compound, you have a molar mass. So all of this ultimately becomes a game of changing units and unit conversions. There is a worksheet attached to this activity that I want you to give a try to. I'm also going to put a link to Chem Team website, which has a whole slew of practice problems. It's actually where I got the 4 that are on your practice worksheet. So if you dig around in there, you can probably find the answers to those. But if you want to look at more examples, they have more examples of how to do some of these conversions, or at least get some hints on where to go with some of these problems. Good luck. Work together. See what you come up with. I will be back tomorrow, so we can practice some more problems together. And if you've got any questions, you can either send them through Schoology, or you can hang on to them and we can go work through them tomorrow. Good luck.